Okay, hello everyone. By the names, I'm Juma Mulabiza. That's a student at Muni University doing MIT in year 3, and I'm here to give some simple explanation about memory management in operating system as an assignment. To start straight to the point, I started with my introduction to the memory management system, and I defined the term memory as a collection of data in a specific format. Yeah, data collected in a certain format that's like its collection, not specifically data, but its collection is the memory. And then memory management, basically in operating system, is so critical in that it is responsible for managing computers' physical memory, that's the RAM, and the virtual memory. And its primary goal is to allocate and deallocate memory resources efficiently to the different processes that will be going on in the operating system. And here we talked of memory management. I mean memory being divided into two parts. That's the first part, which contains the operating system, and then the other part which contains the processes that are executing currently. To go on another slide about memory allocation still, here I talked about contiguous memory allocation, where a process is allocated a single contiguous block of memory, though this may lead to external fragmentation. For fragmentation, we shall look at it in the next slides, but here basically we need to understand what contiguous memory allocation is, and a process is allocated a single contiguous block of memory. Then partitioning. Here we saw two types of partitioning, where there is fixed partitioning and variable partitioning. With fixed partitioning, it depends on it varies with the time t, whereas with variable partitioning, it does not vary with time t, meaning it's independent of time, whereas fixed partitioning is dependent on time. Move to the next slide. Still on memory allocation, here I highlighted more about fragmentation, whereby it's the phenomenon where the continuous allocation and the deallocation of memory leads to the subdivision of free memory space into smaller non-contiguous fragments. Here, the best example is whereby a process may need like maybe 5 blocks of memory, and maybe 6 are available. So it will pick the 5 and leave the 1, meaning that one that has remained, it can't be taken by any process, but it has remained. That's fragmentation. And we have external and internal fragmentation. For external fragmentation, all out memory space is sufficient to fulfill a solicitation. However, it isn't adjacent, so it can't be utilized. That's what I talked of, the example I used in explaining fragmentation itself. Then internal fragmentation, the appointed blocks to a process is greater, meaning some part of memory is left unused. Yeah, that's internal and external fragmentation. Then we talk of paging. Paging divides both logical and physical memory into fixed sized pages. And we have the principle of operation, how paging operates. Firstly, there is division into pages, and this involves breaking both logical and physical memory into fixed sized pages. After breaking them into fixed sized pages, we go to the logical address space. The logical address space of a process is divided into pages of the same size. After dividing the logical address space into pages of the same size, then there we go to the physical memory, where the physical memory is divided into frames of the same size as the pages, meaning these frames have to be of the same size as the pages divided into the logical address space. Yeah, that's the principle of operation. That's how paging operates. And then page allocation, we have a page table, we have a page fault, and a page replacement. For a page table, each process has a page table that maps logical pages to physical frames, meaning that table, it contains, each process has the logical space that the logical page that matches to the physical frames, as seen in the previous slide. Then the page fault, it's when a process references a page not currently in memory. That's a page fault. It's like an error, a process calling a page that is not available. So there we get a page fault as an error. Then page replacement, the operating system selects a page to be replaced, and the required page is brought into the free frame. Meaning, if a page fault occurs, then page replacement has to be done to call for that missing page to be brought into the free frame. Then hardware supporting for paging, hardware support for paging. Here I talked of memory management unit, which is responsible for address translation, converting logical addresses to physical addresses using the page table. So it looks at the page table and converts the logic, and it translates actually. Yeah, then page table base register, that's abbreviated as PTBR. It points to the base of the page table in a memory, meaning it points to the bottom part of the page. It points to the base of the page table. So it goes to the page table and points at the last pages in the page table in memory. Then translation look aside buffer, TLB. It's a cache of page table entries to speed up address translation. That's simply TLB. And then protection and sharing. Still on memory allocation, there should be protection, there should be sharing. Since this is dealing with processes and resources, there should be protection and there should be sharing of the resources. So protection, paging enables memory protection by making pages as read only. Yeah, meaning they can't be edited. Then sharing, shared memory between processes is facilitated by mapping their page tables to the same physical frames. Here I saw some disadvantages of paging, where we talked of it decreases outer continuity. Actually, it decreases outer discontinuity, yet at the same time experience the ill effects of inside fracture. Yeah, and then another one is page table requires additional memory space, and you find that this will go on and it will consume the RAM. Yeah. Then virtual memory, I talked something about virtual memory, is a memory management technique that provides an idealized abstraction of the storage resources that are available on a given machine, meaning it provides a virtual space, a space that actually doesn't exist on a machine. That's virtual memory. And still the hardware and control structures, we talked of MMU, that's memory management unit in the previous slide, page table and page fault. Yeah. And then locality reference, we have temporal locality, spatial locality, and then utilization. Then we have these other terms, working set. The working set of a process is the set of pages that it is actively using during specific time interval. Yeah, so this working set, it's a set of processes in a set of, it's a set of pages that a process is actively using in a certain specific time interval. And then a data page is a page in memory that has been modified since it was last loaded from a disk or since it was last saved to secondary storage. Then demand paging. Demand paging is memory management scheme where pages are loaded into memory only when they are demanded by the program during its execution. Meaning, if there is no program that needs this page, it will not be loaded. If there is a program that needs it, it will be called on demand. That's like demand paging. Then we have the page replacement policies. Optimal, we have optimal first in, first out, that's FIFO. We have second chance, SC. We have not recently used, NRU, and then lastly, recently used, LRU. For optimal, the optimal page replacement algorithm, also known as Belard's optimal algorithm, it selects the page that will not be used for the longest period in the future. Yeah. So this one selects it and it replaces it using that criteria. And then first in, first out, this one replaces the page that has stayed longer or that came in first. Like it arranges them, the page that came in first is replaced first. So the one that has overstayed is replaced first. And then second chance, it uses the same algorithm like FIFO, but this one, it gives a second chance to that page before it is replaced. And then not recently used, NRU, this one replaces the pages that have not been in use like oftenly, that has not been used like frequently. So it picks them and replaces them. And then last recently used, it replaces the page that has not been used for the long period. Yeah. On to the next slide. Here I have the YouTube video. To have a link to the YouTube video explaining this, and basically that's all about the memory management tutorial. Thank you very much for listening. I remain Juma Mulabiza, doing MIT, Muni University, third year. Thank you so much. Bye-bye.